Today we will discuss about measures of dispersion, right? And under measures of dispersion, we will be studying three different things. Number one is called range. Number two is called mean deviation. And number three is called standard deviation. Standard deviation. All of these are formulas, in simple word, to calculate the amount of dispersion, right? Now standard deviation, with standard deviation there is another term that is closely associated, which is called variance, right? So these three are measures of dispersion. So before discussing these three formulas, let us discuss or understand what is dispersion, right? So imagine there are three numbers, 1, 2 and 3, right? So the values are changing at a rate of 1, right? Another set of values, say 0, 2, 4. Here the rate of change is, that means the gap between different values is 2 and 2, right? Now notice that in the first set of value and in the second set of value, if you find out the arithmetic mean or median, in case of median is the middlemost value, so the median here will be 2, here also the median will be 2, because the numbers are in a sequence, right, in a order. So the median is 2, median is 2. Also, if you try to find out the arithmetic mean, 1 plus 2 plus 3 divided by 3 will be 6 divided by 3 equal to 2. Similarly, here also 0 plus 2 plus 4 divided by 3 equal to 6 divided by 3 equal to 2. That means the same number 2 is also the median, also the mean, and both the data set. So imagine this is one data set and this is one data set. Data set means a set of numbers. So both of them has the same arithmetic mean and same median. So if I want to identify or distinguish one over the other, if I have to distinguish this one over this one, then I have nothing to say based on arithmetic mean or median. That means I cannot distinguish between these two data set or these two set of numbers only based on arithmetic mean or median, or in general on the base of central tendency, right? So to identify two different data sets only based on arithmetic mean or median sometimes is not possible. But if I also provide you the information that one data set is changing at a rate of 1 and one data set is changing at a rate of 2, then you can clearly distinguish one from the other, right? That means the amount at which the different numbers are changing or increasing or decreasing is different for these two data sets, right? So this amount of increase or decrease or the difference between different values is called dispersion, right? So dispersion is nothing but the amount of randomness or the amount of difference between the different values in a data set, right? So these three formulas helps us to measure the amount of dispersion or amount of randomness in a data set. Now let's start with range, right? Now range is the simplest example of measures of dispersion. This is the most easy formula. Range is given by, range is equal to maximum value minus minimum value, right? Only the difference between the maximum value and minimum value will give you the range. For example, if the numbers are 2, 7, 8, 11, 29, then the maximum value is 29 and the lowest value is 2. Therefore, range is equal to 29 minus 2 is equal to 27, right? That is one measures of dispersion. The first one is range, right? Now this is simple numbers, ungrouped numbers. Now in case of group numbers, suppose you have a table like this where x and frequencies 2, 3, 4, 5 and 5, 10, 5, 10, then range will be the maximum value minus lowest value. That means 5 minus 2 is 3 will be your range, right? Disregarding your frequencies. So we are not considering the frequencies in calculation of range. Similarly, so this one is your example number 2, right? This is example number 1 where we have simple numbers, ungrouped numbers. This is discrete frequency. And in case of continuous frequency, for example, if you have 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60 with some frequencies f 2, 3, 7, 8, 6, then this will be the class interval. In that case, range will be, what is the last value? That is 60. What is the first value? That is 10. So range is 50, right? So it's quite simple. You just have to subtract the minimum value from the maximum value. The difference between your minimum value and maximum value will give you the range. The next one, the measures of dispersion is mean, deviation. Mean deviation, in short we call it as MD. Okay, so let x1, x2 up to xn are n observations and A is the average of the data, right? Now by average here I am not particularly meaning arithmetic mean. This average can be either arithmetic mean, geometric mean, harmonic mean, median or mode, right? It can be any one of them. This A can either be arithmetic mean, geometric mean, harmonic mean, median or mode. It can be anything. So we have a data set x1, x2 or simply numbers. We have n numbers and the average of those numbers is denote, let's say is A, right? Then the mean deviation is given by MD is equal to 1 by n summation I goes from 1 to n xi minus A, and this sign is called modulus. Now what is modulus? Modulus will disregard the sign. It will take only the positive quantity. So even if you write modulus minus 5, that will be 5, right? So this is the formula for mean deviation, 1 by n summation I goes from 1. That means from all the observations we will subtract that particular average. We will take the modulus, that means we will disregard the signs whether plus or minus, and then we will add those deviations. These are called deviations. We will add those deviations and then we will divide it by number of observations, right? So in place of A, you can take either arithmetic mean, geometric mean, harmonic mean, median or mode. It's up to you. If you take A as arithmetic mean, it is called, if A is taken as arithmetic mean, then it is called mean deviation about mean, right? So this is the name if you use arithmetic mean in place of a. If you use median, that will be called mean deviation about median, right? So this is the formula. Let's now this will be for ungrouped data, right? Now what if we have frequencies? So in case of frequencies, in case of grouped frequency data, mean deviation is 1 by capital N, summation I goes from 1 to n, the frequency modulus xi minus a. This is the formula in case you have frequencies, right? So let's take an example, right? So let's take the numbers are 18, 26, 15, 20, 17, 12 and 25. These are your numbers and we are supposed to find out what is the mean deviation. So by default, if you are asked to find out mean deviation, it means that you are supposed to find out mean deviation about mean. That means about arithmetic mean. So in this example, if you are to find out the mean deviation, then first step is to find out the average, right? So solution here, x bar is equal to 18 plus 26 plus 15 plus 20 plus 17 plus 12 plus 25 divided by how many observations? 1, 2, 3, 4, 5, 6, 7. So 7 observations. So this will give you the average as 133 divided by 7, which is equal to 19, right? So this is the average. So now we have to find out the mean deviation. Now mean deviation about mean is given by one by n. Now this is a case of discrete data, no frequencies, so we will use this formula, 1 by n summation I goes from 1 to n modulus xi minus a, or let's be specific, we will replace a by arithmetic mean. So this is the formula for mean deviation about mean, right? So this is the formula. So for this we will have to find out the difference between xi, that means all these values are xi, x1, x2, x3, x4, x5, x6 and x7, and then we will have to subtract this mean. Mean is 19, right? X bar is 19. So in short, we will have to minus 19 from all of them, then we will have to add the values, right? So for this, to make this calculation simple, we will make a table, okay? For calculation, we construct the following table. Right? So here you will have x, xi minus x bar, and finally xi minus x bar modulus. Right? So these are the 3 columns that we will have to create for this calculation. Now what are the values of x? 18, 26, 15, 20, then 17, 12 and 25. These are our data. Now we have to find out what is x bar. X bar is 19, right? So we basically have to find out 18 minus 19, 26 minus 19, 15 minus 19, 20 minus 19, 17 minus 19, 12 minus 19 and 25 minus 19. What are the values? These are supposed to be found out, right? So 18 minus 19 obviously is minus 1. This would be 7. This would be minus 4. This would be 1. This will be minus 2. This will be minus 7. This will be 6. Right? These are the values. So these are xi minus x bar. The next step is to find out the modulus. That means you just have to ignore the signs. Minus 1 will be 1. 7 will be 7. Minus 4 will be 4. 1 will be 1. Minus 2 will be 2. Minus 7 will be 7. 6 will be 6. And we need the total of this column. This column, the total will be summation modulus xi minus x bar. So what will be the total of this value? 1 plus 7, 8. 8 plus 4 is 12. 12 plus 1 is 13. 13 plus 2 is 15. 15 plus 7 is 22. 22 plus 6 is 28. Right? Therefore, summation I goes from 1 to n xi minus x bar is equal to 26. Now, mean deviation is 1 by n summation xi minus x bar, right? So this is what is n? N is the number of observations. Here in this case we have 7 observations. So 1 by 7 into 28, which is equal to 4, right? So that means we found out that mean deviation about mean is 4. Okay. Now for the same data, if it is not mentioned whether you have to calculate mean deviation about mean, or if it is specifically mentioned that you have to find out mean deviation about median, right? In some cases, it may be appropriate to find out mean deviation about median instead of mean. So let's see how we can calculate mean deviation about median. Right? So the data is 18, 26, same data 15, 20, 17, 12 and 25. The question is calculate mean deviation about median, right? We are to find out mean deviation about median. So to find out mean deviation median, first thing you will have to find out median, right? So to find out median, the first step is to arrange your data in increasing or decreasing order. So solution. At first, we arrange the data in increasing order. So what will be the order? The lowest value will be 12, followed by 15, followed by 17, then 18, then 20, then 25, and last will be 26. 7 observations. 1, 2, 3, 4, 5, 6, 7. 7 means odd. Here n equal to 7 is odd. Therefore, median is equal to n plus 1 by 2th term. Value of n plus 1th term is value of what is n? 7 plus 1 by 2th term. Now 7 plus 1 is 8 by 2, that means value of 4th term. Now what is 4th term? 1, 2, 3, 4, that means this is the median, is equal to 18. Therefore, in this case, median is equal to 80. Let us denote median by capital M. Okay, for ease of calculation, let us denote this median by capital M. Now we have to find out the mean deviation about median. Okay, the mean deviation about median M is given by MD is equal to 1 by n summation xi minus m modulus, right? Now we will construct a table, the same structure. Just like for mean, we will again construct a table to calculate the different values of xi minus m. We construct the following table. We construct the following table. What are the tables? First you will have x minus m, right? M means median, then xi minus m, right? You will have different values. So what are the different values of x? It was 18, 26, 15, 20, 17, 12 and 25. Now xi minus m is median is 18. So you will have to subtract 18 from all of them, right? That means you have to find 18 minus 18, 26 minus 18, 15 minus 18, 20 minus 18, 17 minus 18, 12 minus 18 and last 25 minus 18. So this will be 0, this will be 8, this will be minus 3, this will be 2, this will be minus 1, this will be minus 6 and this will be 7, right? So now if you ignore the signs, 0 will be 0, 8 will be 8, minus 3 will be 3, 2 will be 2, minus 1 will be 1, minus 6 will be 6 and last one will be 7. So we are interested in the total of this column, right? That means summation modulus xi minus m, and the total of this will be 8 plus 3 is 11, 11 plus 2 is 13, 13 plus 1 is 14, 14 plus 6 is 20, 20 plus 7 is 27, right? So summation. Now MD is equal to 1 by n summation xi minus m is equal to, what is the number of observation? It is 7 into 27, right? So this is 3.9. So we got that mean deviation about median is 3.9 and mean deviation about mean is 4, right? So that is how we calculate mean deviation. Okay, let's take another example where we deal with continuous frequency. Okay, let's take the example that we have certain class intervals such as 10 to 20 20 to 30, 30 to 40, 40 to 50, and 50 to 60. So these are class intervals, and we have certain frequencies. Frequencies means how many numbers falls in this range. That means 7, 10, 20, 10 and 3, right? So these are class interval, these are frequencies. We are to find out the mean deviation about mean. So our objective is to find out mean deviation about mean, right? So in this case, mean deviation about mean is given by, so solution, mean deviation about mean in case of grouped or in case of continuous, not grouped, in case of continuous frequency data is given by mean deviation about mean. Now writing this mean in the subscript is purely optional. You can simply write mean deviation, that's fine. Mean deviation about mean is, in case of group, it is 1 by capital N, summation I goes from 1 to N, frequencies modulus xi minus a, right? Or to be specific, in case of mean, it will be x bar. So this is the formula, right? 1 by n, summation I goes from 1 to n, fi xi minus x bar. So the first step is, obviously you will have to find out what is the x bar, because we don't know the mean, right? So we will create a table. For calculation, we construct the following table. So in this table we have class intervals, we have frequencies. Frequencies are denoted by f, right? Then we will have mid values. Mid values are denoted by x, right? So these are frequency which are denoted by f. Mid values are x. Now after this, to calculate arithmetic mean, we will need the multiplication of f and x, right? So if you have any doubt, you can go back and visit the arithmetic mean, right? Arithmetic, where we have calculated arithmetic mean for group frequency data, we need fx, right? Because x bar in case of group data is 1 by n summation fx, right? So for that we need fx. Now for this calculation we need first of all xi minus x bar. So we will need xi minus x bar. Then we need modulus of xi minus x bar. And last we need f into xi minus x bar, right? So this you can write fi xi, these are xi, these are fi, if you want to be consistent. So this is the table that you will need to calculate mean deviation, right? So to calculate mean deviation, you will need these values. So what are the class intervals? 10 to 20, 20 to 30, 30 to 40, 40 to 50, and lastly 50 to 60, right? Now what are the frequencies? Frequencies are 7, 10, 20, 10 and 3. We need the mid values. Mid values means the middle point of 10 and 20. How to calculate? Just add them. That means 10 plus 20 divided by 2. This is 30 divided by 2 is 15. So the mid value will be 50. 20 plus 30, 50, 50 divided by 2, so 25. Next one will be 35, next one is 45, and last one is 55. Right? So need the calculations of this into this. That means 7 into 15, which is 105. This one will be 250. This one will be 700. This one will be 450, and this one will be 165. Now we need the total of this column, F frequency, which will give you capital N. Capital N means total frequency. Now 7 plus 10 is 17, 17 plus 20 is 37, 37 plus 10 is 47, plus 3 is 50. That means total frequency is 50. Now we need the total of this summation fx. What is total? 105, 250. If you add all of this, you will get 1670. Now once you get this fx and summation n or capital N, you can find out the year. Okay, let me remove these values. Now after this table we will write here x bar is 1 by n summation fx is equal to 1670 by 50, which is equal to 33.4. Right? So this is the value of your arithmetic mean. Now we are to subtract this 33.4 from all this value of x. That means we need to find out 15 minus 33.4. We need to find out 25 minus 33.4. We need to find out 35 minus 33.4, 45 minus 33.4, and 55 minus 33.4. So these values are 18.4, 8.4, 1.6, 11.6, and 21.6. Now this you will have minus here because we are subtracting greater value from a smaller value. So ultimately if you take the modulus, this will be 18.4, this will be 8.4, this will be 1.6, this will be 11.6, and this will be 21.6. And the last you have to multiply these values with the corresponding frequencies. That means 18.4 into 7, which is 128.8. 8.4 into 10, obviously 84. 1.6 into 20 will be 32, right? 11.6 into 10 will be 116, and 21.6 into 3 will give you 64.8, right? Now we need the total of this column. That means summation f x minus x bar. This value is, if you add this 128.8, 84, 32, 116 and 64.8, you will get 425.6, right? This is the value. So now mean deviation about mean is equal to 1 by n summation fi xi minus x bar. Now what is n? N is 50, and this summation we got as 425.6. So the ultimate result is 8.5. So this is the mean deviation about mean for that particular data set. Now this is how we calculate mean deviation for discrete data as well as group data, right? So that's all for this one. In the next one we will carry on and we will continue with standard deviation and variance, right? See you in the next one.